This problem is about finding two numbers that sum up to reach a target value. And in this problem, the nums is in the list of integers, and we cannot repeat a number again. So the two indices must be unique, and we can return them in any order. And we're told that also there's guaranteed to be at least one solution, so we don't need to consider any other cases. Now I want to show two different approaches. The first one would be a kind of intuitive solution that is kind of just brute forcing the list by trying to match every single combination of pairs until we reach a solution. And then I will show a more optimized solution such that we don't need to loop through the list more than once. So if you think about what we need to actually do, check all of the pairs, we want to do a nested for loop where the outer for loop is the first value and the inner loop is the second value. So we need to know what the length of the nums is so that we can actually iterate correctly. And we want to go through for I in range of lambdas, and then we want to do another loop for the second value. And then if nums I plus nums j is equal to target, then we can return the indices I and j. Now, one thing to note is that because we cannot use the same element twice in our range for the second value, we must, or the first value, it doesn't matter, but we must, at least in one of them, start from 1 so that we're not checking the same index twice, as we're not allowed to do that. And so this is all we need really to find a solution, as there has to be at least one solution. So if you run this, it should pass the test cases, but this will not pass our complexity requirement of it being in linear time. And to do that, we need to think a bit more differently about how or what we need to actually check. So instead of checking every single pair combination, it would be much more efficient if we could just go through one at a time and check whether or not the current value that we're at satisfies a correct pair. And we can do this really easily because we only have two numbers. And so whatever number we're at is one of them, and we only need to check whether or not there is an adjacent pair that can complete the sum such that we reach the target. And so instead of doing a nested loop, we will still have a loop, but we will be going exactly once. And we want to think of this as storing whatever amount we need, such that we can check if that amount exists, if that amount is equal to the value of the num that is at that index in the list. So in our loop, we will basically have num equals num I, and we want to check if that num is in the dictionary. So our dictionary basically contains the remaining values, and this is going to be a dictionary of integer where the integer is the key is the amount necessary to complete the target, and what we're actually going to be storing is the index of the second value. So we're basically storing we're storing the value as index of j, and we are looking for I which matches a key. And so that is kind of the intuition behind this. And so when we set num to the current value, we want to check if that num is in the keys of our dictionary. So if num in remaining values dot keys, then we know that actually this value is the correct, well, forms the correct pair, as that's the only way that we can match up the indices. And so if that num is in the keys, then we want to find what the in J index is, and that's just going to be in remaining values, and we're going to be looking up that remaining number, which is the key. As remember, we are storing the keys as the remaining value required to fulfill the target value. So once we have that, we can simply return I and j. Now, if that is not the case, so this is our base case to exit the loop. If we have not reached that, then that means that we need to add to the dictionary how much we need in order to fulfill this pair. So this is a case where I is the second value. So remaining values, target minus num. So that's the value that we're looking for in the next iterations to fulfill this. So that will be set to I. And so this will also be guaranteed to find a solution, and that would be a lot more efficient. I forgot. So if you run this, it should be the most optimal solution. And so that's all for this problem, and thank you for watching.